Organic chemistry, the acidity is referred to the weak organic acid. So, for more acidic, the Ka will higher, so pKa will lower, and it means this is a more acidic. To determine the strength of acidity in organic chemistry, so we'll identify which the conjugate base can be stabilized. It means it's a more acidic. So how we know the conjugate base is more stabilized is when the electron decrease. So it is more stabilized. To discuss the acidity, we need to look back our prior knowledge in terms of carboxylic ion and the chemical equilibrium. So as we know, the carboxylic acid they will donate the proton to the H2O, and H2O will accept the proton to become the carboxylic ion. So we'll discuss the electron density in carboxylic ion, whether increase or decrease. So electron density will determine the ion stable or not, and determine the acidity. So first one, to discuss the carboxylic ion. So when you look at the chapter 4 about the stability of carbon anion, we will find that tertiary carbon anion is less stable compared to methyl carbon anion, because carbon anion meaning is full of electron, and the R is the electron donating group. So electron donating group will increase the electron density. So the carbon anion is less stable. So what's meaning by carbon anion already full of electron, but you give more electron to them, so they'll feel very unstable. Like example, you're already full, but people give you more food, so you feel like warming and not comfortable. So this meaning by the tertiary carbon anion is less stable compared to methyl. So that means conclusion, if the electron density for the carbon anion or carboxylic ion, if the electron density is less, so electron density is less, it means the ion is more stable and more acidic. So when the electron density higher, it means less stable the ion and less acidic. So we look at how the electron density will lower. Okay, so before we go to factor, now we'll discuss if this one ion for the carboxylic ion is stable, it means the intercapillary principle, the reaction will move forward and produce more H2O plus. So we'll discuss what's the factor will influence the electron density of the ion. The factor influence acidity is divided by 3. First one, resonance effect. Number 2, inductive effect. Number 3 is the number of COH group and OH group. So first one, for resonance effect, so we will look at how the negative charge of carboxylic ion can be delocalized, so they're more stable, more acidic. So this is trend for the acidity. Now we look at the alcohol. So alcohol, when the alcohol lost the H become O minus alkoxide ion, the electron is localized at the O minus. Localized means the electron was static at the one place, so largest electron density. How about H2O? H2O is amphoteric, so it can accept or donate the proton, so it become OH minus. So electron density of the OH minus is less than RO minus, because alcohol, the R here is a function electron donating group, so it will increase the electron density. So it means like compare with these two, alkoxide ion, alcohol and water. So the water is more acidic compared to the alcohol, because the presence of EDG and alcohol. So the next one is phenol. After phenol lost the proton, will form phenolcyclide ion. The electron will delocalize around the O and on the benzene ring. So make it the electron density not located at O minus only, but it can delocalize, can move around the benzene ring, so it will reduce the electron density. But how about the carboxylate ion? Carboxylate ion is a O minus, so because this is a C double bond O and O minus, the electron density can be delocalized between the two electron negative O. So they can form the resonance like this. So the electron density can be delocalized between these two O. So what's the difference between the carboxylic ion and phenoxide ion? Both can delocalize, but why carboxylic ion is more acidic? So the reason is the electron delocalized between the two O, and where is O is very electron negative. But the oxygen at phenol ion, the electron density is localized between the O and the carbon. The carbon is less electron negative than O. So it means that the carboxylic ion, you have a two very electron negative O to attract the electron, compared to the phenol is evolved O and less negative O and less negative carbon. So the electron density of the carboxylic ion is decreased compared to more smaller compared to the phenoxide ion. So make it the carboxylic ion is more stable. So now we look at the pKa value. So pKa value smaller, more acidic. So you can find that pK value smaller is carboxylic ion 4.8, and then followed by 10. Okay, so you will find that the less acidic is alcohol, followed by water, and followed by phenol, and followed by the smallest one is a carboxylic acid. So this is a slide to explain the acidity for the 4 example. So you can overview the points I mentioned just now. So another factor if discuss inductive effect and number of COH, OH. So I discuss the factor number 3 first. So when you found the structure contain more COH, right, it means, or more OH, right, it means it will give more H plus in the solution. So there was higher acidity compared to others. So let's say example, for this example, dicarboxylic acid is more acidic than the one carboxylic acid. This one DiO is more acidic compared with the ethanol. So now we focus to the inductive effect. So inductive effect is talking about EWG and EDG. EWG, the example we can discuss is, let's say EW is electron withdrawing group. So they can be halogen. So the halogen is referred to the Cl or Br or F, anything talking about group 17. And the one next is a Cn minus. Next is the NO2. Is more common EWG. For EDG usually is the R group or involve the long tail like NH2. So this one is talking about EWG. Okay, now we continue how the EWG and EDG give the effect of the acidity. Right, the first one we discuss is number of EWG. So number of EWG meaning now this is a carbon 1, carbon 2. So this one carbon 1, carbon 2, carbon 1, carbon 2. Carbon 2 you have a 1 EWG, carbon 2 you have a 2, and this example carbon 2 you have a 3 EWG. So carbon 2 contain 1 EWG, that means that inductive effect weaker. Electron density may be big like this, but you have a 3, that means electron density was smaller. So that means according to our theory, electron density is smaller, more stable, and more acidic. So that's why the 3 EWG give the more stable ion and more acidic. So after we discuss quantity or number of EWG, now we discuss the second factor is the position of EWG. So now EWG here is chlorine, carbon 1, carbon 2, carbon 3. Carbon 1, carbon 2, carbon 3. First example, EWG at carbon 3. Second example, EWG at carbon 2. So EWG at carbon 3 is further than the carbon 1. So it will give a weaker attraction to COO minus. So the electron density is quite big. But because the position of the Cl at carbon 2 is nearest to CO minus, so it gives a greater greater inductive effect, so electron density is smaller. So go back to our concept, when the electron density reduce, it's more stable and more acidic. So it means the answer more nearest to the COO minus, the acid is more acidic. Okay, next is a type of EWG. So according to our electronegativity theory, carbon is more electronegative than Cl and Br and I. So it means that F will highest electronegativity compared to others group 17 member. Now we look at what's the difference. Carbon 1, carbon 2. So carbon 2 is F, and carbon 2 here is Cl. So we know F and Cl, F maybe will attract 5 Newton, and the Cl maybe will attract 3 Newton. So it means that the electron density at the first carboxylic ion electron density is smaller because they attract 5 Newton. But for the Cl, they attract 3 Newton, electron density will higher. So student, can you guess which one is more stable or more acidic? Yes, the answer is this one. Because electron density is smaller, the ion is more stable. This is more acidic. Alright, thank you class. So hopefully you get some idea about how to determine the acidity. Thank you.